So last time we talked about radical expressions and specifically simplifying them, combining like terms, all that kind of good stuff. Just like we talked about at one point, regular algebraic expressions with variables and simplifying them and that kind of stuff. So now we're going to move into, just like we moved from algebraic expressions, and then we moved into algebraic equations, we're going to move from radical expressions to radical equations. And so we have a couple different options on how we want to use variables and radicals. And so the first thing we're going to talk about is the variable as the radicand. Okay, so what that would look like is, let's say I have y equal to 3 radical x. And the idea is that, remember how we said we didn't really like radicals and denominators because they're hard to work with? Well, if I'm going to try to solve an equation, I don't necessarily want a radical. It makes it a little bit harder to solve. So my idea is here that we're going to break down this equation and try to get x by itself. And that would actually also mean to get x out of the radical. So the first thing I need to do to get x by itself is to divide both sides by 3. Okay, that way these cancel, and I'm left with y over 3 equals radical x. Then, the opposite of a square root is a square. So I can go ahead and I can square both sides. Okay, so this becomes y squared over 9 because I do square top and bottom. And this just becomes x. Okay, it breaks out of the radical. And that's an equation I can work with and solve. I can plug in values of x and y a little bit easier if I'm not working inside a radical. So that's if I have a variable as the radicand. Lots of times, however, I will have an expression as a radicand. So this might look something more like the square root of a plus 5. And I can cap my square root like that to show that these things belong in the square root, and this plus 7 I'm going to add on does not. And we'll set that equal to 12. Okay, so there's my problem. Again, I'm going to try to get a by itself, which means getting, I guess, the radical by itself first, and then within the radical we can move things around. So the first thing I want to get rid of is that 7, and I'm going to subtract 7 off both sides. So then I have the square root of a plus 5 equal to 5. And just like in the last problem, our next step to get rid of the radical is going to be to square both sides. So I have a plus 5, when it comes out of the radical, equal to 25. Now this is a one-step equation you can solve. I subtract 5 on both sides, and I get a equal to 20. Okay, I'm going to have you practice one on your own. We'll do square root of c minus 3 minus 2 equals 4. So go ahead and try that one. Check your work against mine, but when you solve, you should get that c equals 39. And we'll try one more for giggles and grins. 4 plus the square root of n plus 1 equal to 14. Try that one. Again, check your work, but we should have gotten n equals 99 this time. Okay. The last way we use radicands is with a variable on each side. And so this might look something like the square root of k plus 1 equal to k minus 1. So I have a radicand on one or both sides, probably just one while we're starting to practice, but I do have variables on both sides. So instead of moving things around to start, what I'm going to do is I'm going to start by getting rid of the radical. So square both sides. So when I square the radical, I just get that k plus 1. When I square this is almost like a FOIL problem. So I have k minus 1 times k minus 1. Okay, so I'm going to go through and FOIL, and I'll get k squared minus 2k plus 1. Okay, make sure you get all those terms. Don't just say k squared plus 1. You want to get that middle term in there. And then I can start moving things into one equation. So I started this problem by subtracting k's off both sides, and I'm going to line up where that goes. That way these cancel. I get 1 equals k squared minus 3k plus 1. Then I really also want to get rid of this one so that I can set it equal to 0. So I'm going to subtract 1 on both sides. And I get 0 equals k squared minus 3k, because these ones cancel as well. Well, then I can see something that I could factor. So I can see that each one of these terms has a k, so I'm going to pull a k out, and I'm left with k minus 3. Okay? And that's, of course, equal to 0. To solve for k, because I do want to solve for my variable, I'm going to set each factor equal to 0. So I'm going to say k is equal to 0, and k minus 3 is equal to 0. This one is already solved, but this one I'm going to add 3 to both sides so that I get k by itself, and k is equal to 3. So then my solution set for this problem would be k is equal to 0 or 3. Okay? Let's have some practice problems with this for you to try. So we'll do the square root of t plus 5 equal to t plus 3. Try that one. So I started off by squaring both sides, which means I had to FOIL this. Then I subtracted things over so that eventually I got the 0 equals a polynomial. This polynomial was a little different to factor because it wasn't like I took just the t out or whatever. I actually broke down and factored this to t plus 4 and t plus 1. I set both factors equal to 0, so t plus 4 equals 0, t plus 1 equals 0, and solve for my t value. So I got -4 and -1. Try just one more of these on your own. We'll do x minus 3 equal to the square root of x minus 1. Hopefully you followed some of the same steps from last time. Go ahead and check your work, but you should have gotten x equals 5 and x equals 2.